All right, I've got a tank of distilled water here running with a pH of 7.5. The question I have for you is, what do you think is going to happen on this pH scale when I add CO2 to this water? We're currently right here. Where do you think we're headed? All right, so I've got this disposable CO2 can here from ISTA, and I'm going to blast this water with CO2, and let's see what happens to the pH. Okay, so we have the CO2 in the water. Now let's see what happened to the pH. About 5.5, getting down there to 5.4 range. So it's quite a bit more acidic. Now, did you guess right? Let's take a look at where we were. We were at 7.5, and now we're down closer to 5.5. And remember, this is not just one single point. The difference between these is a factor of 10, which means that 7 to 6 is 10 times more acidic, but we went from 7.5 to 5.5, that's 100 times more acidic. So as you can tell, there is a drastic effect to pH with CO2. But what else affects pH? Come with me, let's take a look. If we take one of our aquariums here, for example, the lights are off. So if the lights are off, then the photosynthesis isn't taking place, which means that the plants are not absorbing CO2 and producing oxygen. So when they're not absorbing CO2, you have more CO2 in the water, and we just found out that that makes the pH slightly lower, right? Now, we obviously made a big difference in this one because we blasted it with CO2, but that's clearly not what you're doing in a tank, so it's not gonna have that drastic of an effect, but CO2 will lower the pH a little bit. Now, if you come in here and turn on the light, which I'll just connect right here, not only do you see an awesome looking aquarium, I must say, but also you've got these plants are gonna start doing their photosynthesis, they're gonna start absorbing that CO2, and when they absorb the CO2, there's less CO2 in the water, and therefore your pH will come up. So there's different ways in which you can affect aquarium pH just by doing the normal stuff that you're typically doing. But what some of you may be wondering is, what's really going on behind the scenes here? Let's take a look. Okay, so stick with me here, guys, because this is really important to understanding exactly how pH works. So we added CO2 to water, right? We watched that happen. And let me just draw out in a couple different ways what exactly was happening when we did that. So initially we created something like this, which is called carbonic acid. So we know that the water got a little bit more acidic. Now what happens with this is it does something called dissociate. So it dissociates in water, and what ends up happening is you get one of these hydrogens off into solution. It's free in solution, right? And what then happens is you have HCO3, which is called bicarbonate. All right, now this actually is gonna happen one more time. It's gonna dissociate again, and this is all really important to understanding how the pH is measured. You have your oxygens, but now you have 2 hydrogen ions free in the water, and you've then created CO3, which is known as carbonate. And you've probably heard of carbonate because that's sodium carbonate or calcium carbonate. These are common things in the aquarium industry. But what's so important here is this right here is exactly what pH is measuring, the free hydrogen ions in the solution. All right, so we're back here with our pH scale, and what pH is measuring is the negative log of the hydrogen ions in your solution. That means, the negative log means the more of these little hydrogen ions that you've got floating around in solution, the lower your pH is going to be, okay? So, why does this all matter? Well, life exists here. Life exists in these tanks, and life requires proteins, and proteins require a specific pH level. You've probably heard about this fish or that fish needs to have a certain pH or that sort of thing. Of course, do all your research on pH requirements for your fish, but typically there's a range, and that's why it's important to understand the things that affect pH. The things that affect pH are woods, and rocks, and soil, and CO2, and plants, and all the things we do to our tanks affect pH. But here's the thing you gotta remember, you guys. It isn't about chasing the pH number. It's about stabilizing your pH. okay? Here's what happens. If pH fluctuates, if these little free floating hydrogen ions, if you have a bunch of them and then they go away, they get sucked back up into this molecule and then they're back out floating again, if that is happening too much and you're getting wild pH swings in your aquarium, what's gonna happen is it's gonna stress out your fish, they're gonna get sick, and they could potentially even die. So what I think is the thing that most new people to this hobby do wrong is they chase pH. They start to measure pH and they're always trying to get to an exact decimal. When in reality, what you want to be doing is you want to be measuring your KH. Whoa, wait, what? You were just telling me about pH this whole time and all these different things that can affect it, and now you're talking about KH? Yeah. KH is sort of the hidden thing back there that most people don't talk about, but in reality, it's what stabilizes pH. Let me show you what I mean. So KH is the measure of the carbonate and bicarbonate in your water. In other words, what it is the amount of these molecules that exist in solution that have the ability to essentially vacuum up these hydrogen ions. And when they do, when these hydrogen ions get reconnected here to the oxygen, then you have less of them floating around in solution, which makes your water less acidic. All right, so what carbonate hardness is actually doing is it's buffering your water, or it's actually increasing your water's capability of buffering your pH, meaning stabilizing your pH, just keeping it from swinging all over the place. There's a couple ways you can do that. Number one is you can add an aqua soil. So this is an active substrate. This particular aqua soil here is UNS contra soil. And what this does is it actually has a buffering capacity which keeps your pH typically around a 6.8 is their target. And plants like that, and shrimp like that, and most of all of your inhabitants in aquaria like that too. So perfectly within range, but most importantly, it stabilizes your pH so that it doesn't go swinging all over the place. So aqua soil is one way. Another option is crushed coral. And the reason why crushed coral is cool is because it will buffer your pH for a long, long time. And it is calcium carbonate. That's what makes up coral, right? When you put calcium carbonate in, you're putting calcium element in your water, and that is good for your fish's bony structure and their development, but you're also putting carbonate back in the water. Check it out. Remember this? You're putting carbonate back in the water, and that is going to act as a vacuum for these hydrogen ions. The more carbonate you put back in the water, the more opportunity for those hydrogen ions to reconnect. It vacuums them up, the less of them floating out, right? The higher your pH is, and the more stable your pH will ultimately become. Well, why does that stabilize your pH? And why are you still holding this bag of coral? I'm wondering the same thing. It stabilizes your pH because when at first, right, those hydrogen ions are dissociating off into free form and your pH is going down, well, now you're adding carbonate back in, it's grabbing those ions, and your pH is going up. And this up and down thing actually finds an equilibrium, right? And so if you can add to your water things that are going to suck up or vacuum up these hydrogen ions about as fast as they are getting released, then you don't have the big swings of pH. And that's how that works. So what do you do with this crushed coral, by the way? Well, you can put it in your trays. So if you have a filter, whether it's a canister filter or even a hang on the back filter, for example, throw some of this crushed coral in your tray. You can put it in a mesh bag, put it in your tray, and as the water runs over it over time, it will continue to add carbonate to your water, stabilizing your pH. Now, the cool thing about all this stuff is it's measurable. All right, so what you got to do is get yourself a test kit. I love this one from NT Labs because it's super comprehensive, tests everything that you need, including KH. And the cool thing about the KH test, you guys, is the KH test is immediate. You don't have to wait 2 to 10 minutes like you do on some of the other ones, which obviously is not a huge deal, but it's nice that this one's right off the bat. So you take this KH solution, and what it's going to do is it's going to measure your degrees KH. That's just how it gets measured. And the way it's going to do that is every drop that you put in is 1 degree, and what you're waiting for is for this to turn yellow. So I'm going to, you'll see some yellowing right off the bat, and get that air bubble off. You'll see some yellowing right off the bat. 2, 3, 4, 5, 6. 7. I think we'll probably be in that neighborhood. Still a little bit light. Throw one more drop in there. And I'm just going to cap that off. Yep, that's a good yellow color. How do you know? You can just flip this around and you can compare it right there. And what that tells you is, as long as you've got 7 or more drops to get it to that yellow, your degrees carbonate hardness is where you want it to be. And the reason why that's important is that's telling me that my water has good buffering capacity, which means that my pH is not going to be swinging around, which means that my fish are going to be healthy.